Hello everybody, welcome to Geoscience Australia's public lecture theatre or lecture, public presentation, all of those things, and hopefully and a whole lot more. My name's Steve Hill, I'm the Chief Scientist at Geoscience Australia. I'm today's presenter, but I've also been given the keys to be the chair of the session and introduce myself. The lunatics are finally running the asylum. What am I going to say about myself? I'm going to keep it really short, actually. So thanks everyone for joining us. Before I go any further into introductions and so forth, I would just also like to acknowledge the traditional owners and custodians of the country throughout Australia, but also elsewhere in the world. I think we might have a few people from overseas, if not watching it live, watching recordings. And I'd like to acknowledge the continuing connection to land, waters, sky and community. Really relevant because a big part of my passion, but also what I have in the talk here is about connection to the earth. So a very relevant part. We pay our respects to the people, the cultures and the elders past and present. But as I said, also welcome to all of you. Thanks for joining us either in person, online, or in recording in the future. As I said, my name's Steve Hill. I'm the Chief Scientist at Geoscience Australia. I started at Geoscience Australia in late 2018, so I think that means I've been here for about 6.5, coming up to 7 years in October at Geoscience Australia. Been an amazing place to work. The mission and vision for Geoscience Australia is just incredible, with phenomenal people doing phenomenal things for the benefit of our nation, and I love being right in the middle of that. Prior to that, I was the Chief Government Geologist for South Australia, and as well as that, the Director of the South Australian Geological Survey. I think I did that for about 6 or so years, and I love that, doing things like establishing a core library and getting a government to approve such a construction and some of the real groundbreaking projects that we did in pre-competitive geoscience. And then prior to that, I was an academic at the University of Adelaide, as well as the University of Canberra. I think I had a career as an academic for about 20 years. I know you all look at me, you must think I must have started as a mere infant. And prior to that, I studied at ANU for a PhD, undergraduate at Melbourne University, all those things. Let's get on with the talk, Steve. Okay, so as I said, my role here at Geoscience Australia is as Chief Scientist. As such, I'd like to provide a seminar today that touches on that role, but not about defining the role. I've done that before. The last Geoscience Australia public seminar I gave was about launching the science strategy and talking about the science principles. I want to move a little bit on from that and really share some of the insights that have mostly come from the staff at Geoscience Australia and the kind of challenges and questions that we've been faced with. So hopefully you'll be able to join along with me on that. In places I've deliberately not inserted specific examples, because what I'm talking about here is actually the story for all of us, both at Geoscience Australia, but also as scientists outside of Geoscience Australia. And by not inserting my own examples in some parts, it allows you to digress and insert your own experience in that part of the presentation. I hope that works. But I have got some examples as well. So to start things off, I'd like to ask, and it's a great one to ask in this room, for those that are watching online or recording. I've got a room of pretty much all Geoscience Australia staff. But have a think, all of you. When did you first know about careers as a scientist, or specifically even a geoscientist, in government? Did you know about that career path when you were at school? And I'm getting nods in the room. People didn't really. And I think that's exactly right. When I was a student, I didn't know about that career path. I knew people worked as scientists in government, but I didn't really know much about it. And even when I was a lecturer at university, I wasn't familiar enough with the roles to sort of be able to champion it and recommend it to students. I love this photo of Geoscience. This is of Geoscience Australia, standing on top of the hill near Red Hill. It's Davidson's Trig. And Geoscience Australia is, of course, where the bright light and sunshine is emitting at the moment. Every photo's a metaphor. Okay, so it's interesting when we think about that career of particularly of a geoscientist. It's equally applicable, I think, in many ways to scientists in government, but I'm going to talk about geoscientists in government and what they do. The interesting thing is if you ask everybody and even answer the question yourself, you might have different, generally you find that people have quite different answers, and even you yourself, if you are one of these people, will have a different answer at different times to different audiences. And I think that represents, in many ways, the diversity of the role and the diversity within the role. But I think it also represents that it is something that we haven't put a lot of time into trying to articulate. And because it's not well defined or articulated, it means that it's not well presented as an option when choosing a career to aspire to. And so what I want to talk a bit about today is what are some of the universal characteristics of the role? What that means by not having that clear articulation is that there is a limited initial choice or mobility into government scientist roles. And there's also limited mobility out of government roles and into other career paths. And that effectively reduces our diversity and our ability for knowledge creation, both internal to government and also the external to government geoscience community that we look to partner and work with. That then will lead to less innovation and reduce scope and nature of geoscience. And this is something that I will say that I've noticed a lot in government, both here and when I was in state government, is finding people that were ready for partnership with government because they understood the role and the demands and the requirements. So, as I said, I'm hopefully going to cover a lot of that in this presentation, or at the very least, stimulate thought and engagement around that. I was a lecturer for 20 years. The golden rule: tell them what you're going to tell them, and then tell them what you told them. So what I'm going to really focus on here is around that reinforcing that specific expertise silos are one of our biggest challenges. They fragment and limit the impact of geoscience. Secondly, that government scientists, the reality is we work across a range of sectors where trust in our science and people is fundamental. And third, always do it in threes, growing and sustaining geoscience are critical to how we live with the planet and where we need a strong, well-articulated identity to better rally our community. Okay, so buckle up. That's what we're going to cover. So to start off with, let's first have a look at science and geoscience. This gets talked about a lot, particularly at a place called Geoscience Australia, where people go, yeah, I know it's our name, but I'm not a scientist, or I don't work in science, and we don't really do much science anymore, quote unquote. We have transformed into a data, digital and services team, or I don't have a science degree or a PhD, so really, I'm not in that mix. I disagree. We are all part of the geoscience community, whether we see ourselves as lab coat wearing Bunsen burner burning scientists, or whether we're working in corporate nature and making science happen. We're part of that community. Take it back to its fundamental definition, geo meaning earth, science, and I love, this is the definition of science. I know there's lots out there. I'm just trying to give us something to work with. I'll talk a bit more about it in a minute. But really that knowledge and understanding of our environment, meaning the world around us, physical, cultural, so forth, through a systematic methodology based on evidence. Things like observation, measurement, experiment, testing. We do that at Geoscience Australia. I love this quote, and I must acknowledge Colin Payne, who used to work at Geoscience Australia. He actually put this up on Facebook just in the last week, and I thought, a great quote. I'm going to read it, not just in my own voice. I don't know how Joseph E. Armstrong speaks. But science is more than a body of knowledge. Science is the process by which this knowledge is gained. at the present time, far too few people understand this. This lack of understanding allows many people to treat scientific explanations as if they were merely opinions to which their undocumented, unsupported opinions can be equated. This special form of ignorance is growing in influence, a type of know-nothingism that demonstrates the darker side of relying too much on faith and not enough on evidence and reason. That is an amazing quote, especially when we think about the world at the moment, but also when we think about our journey in Geoscience Australia, and perhaps the people that do not necessarily easily and readily connect with being geoscientists. So the other challenge that we have is that many of us also define ourselves not as a geoscientist or earth scientist or whatever you want to call it. Many of us define ourselves by our specific expertise, and there's a tendency to become defenders of our universe, right? The them and us type approach. Often referred to as the silos, the science, internal science silos. This is a really interesting study that we did at Geoscience Australia a few years back. This was part of the science evaluation process, the lead up to that. And we interviewed effectively 457 geoscientists. My apologies, we didn't interview people in hardcore parts of corporate, not because we didn't like them and didn't want to include them, but we wanted to provide a statement about our science. It would be just a bigger universe if we went that way. So we just tried to keep it somewhat succinct. And what we found was, look at this great array of areas of expertise that people kind of define as. But what was also interesting was, and I'm apologising, you probably can't read it, but I'll help you out a bit here. Geology, science support, digital science and information, business management, and geography are the big segments here. Sorry, I should have explained. If you're trying to read this is a sunburst plot. The inner circle is the broad area of expertise, and the outer circle is subdivisions within that. Okay? So what we find is that in government, I'm talking about Australia here, there are scientists and geoscientists at different levels, national, state, territory, local. And that covers several thousand jobs. Australia's Office of Chief Scientist estimates that there are greater than 20,000 science jobs in the Australian national government alone. Geoscience Australia, I'm going to just say we have approximately 700. It's accurate but not precise. But what was interesting from that last plot is that less than 1/8 identify as a geologist, about 1/8 as a geographer, about 1/5 identify as business manager or digital science and information.
How many identify as all of them?
Yeah, that's a great question. But what yes, that's true, and the plot does show that. We've got that in our data. But the point I wanted to make is that we have an incredible diversity within there. Okay, so thank you. The shout out from the audience, because people can't hear it, was, oh, how many people identify as all of them? And it's like, yeah, some do. Not all do though, but some do. Where else in government do we have our scientists? So we have publicly funded research agencies, or PFRAs, so CSIRO and so forth, and Geoscience Australia. But we also have people that are in government/public service departments, and so DISA, DQ, and so forth. And my point that I really wanted to make was that great diversity of expertise. But the thing is, they all come together under that banner of geoscientist. So what does that mean? Really, I want to promote that broad definition of geoscience and the diverse roles where science of the earth is valued and in demand. And geoscience is not just defined by what your lecturer has done in their life. You know, the master lecturer and being told that, oh, well, you're not a real geoscientist because you fall out of the domain of what people have experienced. And it's larger than any individual. Why do we need geoscientists? A picture tells 1,000 words. I love this one that really touches on our community safety branch work at Geoscience Australia. Here is, I won't go away from the microphone too much. Here is a map on the table of flooding up around Cairns from a couple of years back. And here we can see, obviously, important members of our government making decisions and using that data as the context and the evidence for taking plans forward and communicating where we're at. That is exactly right. We need this science, this evidence base in our government to make informed evidence-based scientific decisions. And what that means is that government geoscientists have a key role in our society and for how we best live with the planet. And our government geoscientists need to work with a diversity of stakeholders and have a major impact on all of our lives. So what are some of those characteristics? Well, I've talked a bit about who they are, but I think this is a really important bit that a lot of people miss, is that government geoscientists and government scientists really walk that line between government, research, industry and community. And I think that's a really important skill to be able to walk that line and hold your own and communicate across those different areas. Some of the interesting distinctions is that the publicly funded research agencies, or PFRAs, tend to be very mission-orientated, tend to have long-term research programs of national priority and benefit. And Geoscience Australia is a great example of that. But there's also in areas of government departments and the broader public service, there's that knowledge creation and use, particularly for policy making, societal welfare and national interest. And that does include an element of not only policy, but regulation as well. And a big emphasis on that solving practical problems that directly affect societal or national interests. This is an important part because I think a lot of our scientists at Geoscience Australia, particularly coming from university into government, actually struggle with this a bit. What is our role and how is it different to what I was doing as a researcher in university? And what it means is that we do have a strong focus on applied research and science. Organisational alignment is also critical, and we have a range of key outputs. So there's not the same academic freedom that university researchers might have. Doesn't mean there's none, but it's not the same. There is that applied and alignment, and there's a real diversity of outputs. Makes the metrics and measurement of our work as individuals quite challenging at times. And the really key part is that trusted quality and impartiality of that science that we do and use. The other challenge that we have is sustaining it, sustaining that government geoscientists area. And it comes up a lot is that challenge of recruitment, recruiting the right sort of people. What's interesting is that we rely very heavily on that through flow from university, geoscience and STEM courses. But as we talked about at the start, there's not a great articulation and awareness of the government geoscientist roles at the university level. So that's a really interesting challenge that we face. But the other thing to point out is that when you talk to each of the individual areas of expertise within geoscience, they typically think that they're somewhat unique in having this challenge. I know that the geology sector thinks that they're unique, and they wonder if whether one of the drivers for their challenge in student numbers and producing enough graduates is the stigma of the mining industry. There might be some truth in that, but it's really interesting then when you talk to the geospatial community and they'll tell you they've got the same problems. And I wonder whether it's not a bigger STEM issue rather than an actual cultural, community-orientated challenge that we face. The other thing about it is, in the sustainability, is that many parts of government have a strong education and outreach program. Questacon is a great example at the national level. But I love the way that at Geoscience Australia, we also prioritise and are committed to that education and outreach. It's interesting, though, that at Geoscience Australia, we don't have a direct education mandate. We do it because, one, it's right. We do it because of our engagement needs, particularly for future recruitment, but also community awareness. So those sorts of things are really important to point out. And And I love the way that we still nonetheless prioritise our work of our fabulous education centre. The last point there is an interesting one. When we do engage with universities around this, one of the challenges has been for university departments, particularly the ones that are under threat of closure, to really have a strong awareness of what their business case is. They're very often told that they're closing down because they don't have enough student numbers, but in many cases they're not aware of what the threshold requirement for student numbers is. They often just only know that it's more. And I feel for them because it's an undefined challenge. And I wonder if better defining that business case would make an important difference. And also better, as part of that, better defining the capability and capacity of the different university groups. That would also help us in our partnerships with the universities. That's a whole nother seminar. And lastly, around the role, I want to just mention about our role in not only the nation, but also the world community. We are part of the planet, and we are part of a community of world government agencies, geological surveys and so forth, that ideally are working together towards the well-being and better understanding of our planet. And this is one example that I'm really excited about, and that is the World Community of Geological Surveys. If you don't know about it, we have a website and also a LinkedIn page. I have the good fortune of representing Australia and Geoscience Australia as part of this with this bunch of colleagues here from around the world, from pretty much every habitable continent in that photograph there. This was just at the recent PDAC meeting in Toronto where we had a gathering. And the community spirit, camaraderie and support that comes out of this group, which is a free to join, no membership fee, coalition of the volunteers, is really powerful and actually makes me proud to be a geoscientist on this planet. I'm going to give a little break, just because I'm going to have a slight change of tact. So I'm just going to put up a few little breaker scenes. I'm going to have a little drink of water before I go on to part two. Beautiful part of the world, South Gippsland here. Cape Liptrap, which is down there as well. For those that study structural geology, it's a very famous site, particularly because of all of this amazing rock deformation, but beautiful part of the world. And this is looking into Waratah Bay towards Wilson's Promontory. Great. This is what it's about, hey? This is our planet. And connecting to that and understanding that and working with that and having our society best work with these places is really an amazing inspiration. Hydrated. Ready? Where am I going to throw you now? I'm actually going to move this talk from the sort of greater good of Geoscience Australia and actually start to focus a little bit on you, audience. Okay? To focus on you and what your personal challenges may be. So, let me tell you, as a starting point, that we are awesome, absolutely amazing. We understand the planet better than anyone else at any previous time. We hold the key for our future resource needs and their impacts, minerals, water, energy, soils, oceans, measuring the earth, mapping the earth, etc. Getting carried away, I'm knocking things off the lectern. We can harness our technology to measure, map and observe the earth in ways that we have never done before and use that to feed into our science. And we conduct valuable and important science for the future of our existence. But everyone doesn't seem to know about how awesome we are. I haven't been high-fived at a barbecue for saying that I work at Geoscience Australia for ages. Is it because people don't listen, or is it because they don't understand? And if either of those are true, do we then just tell them more and more facts, better inform them, and do better and better science and keep telling people about that? I'm going to argue that we perhaps don't do that. One of the challenges is, as a society, we forget that we live on a planet. We're so urbanised. We forget that we're currently travelling through space at a speed of 30 kilometres per second, taking us a year to orbit the sun. That's amazing. Imagine if you had a spaceship that did that. We're also rotating at 1,670 kilometres an hour at the equator. We share this with around 8 billion people, as well as many other living organisms. And we're part of an Earth system, and this provides the resources for our lives. I think we forget that. I think we think the supermarket provides most of our resources for our life. I think we think that we're moving as fast as our cars can go. Whatever. We forget that we're part of that planet. We forget then also that we're part of the landscape and part of the country. And I use country in the sense of the place where we live, a little bit like how we acknowledged country at the start of this. And a lot of it's because we're highly urbanised. We concrete, we pave, we bitumise, we landscape, we improve our environment. We forget about it. We may still be at a valley bottom, but when it floods, we're shocked. We may live on a fault line that's active, and when there's an earthquake, we wonder what the government's doing about it. So as a society, we have a poor recognition also of those supply chains and how we live with the earth. So let's go back to that, how people don't know necessarily how awesome we are. And let's have a bit of a think about how we communicate our knowledge and how we engage. As scientists, we have a tendency to want to communicate in matters of fact rather than matters of concern. And I know Ian Stewart, very well known science communicator, geologist, talks about this really well. And I must pay respect there and say that Ian's discussion about this has really inspired me around this area. I think he's spot on. So that matters of fact rather than matters of concern. Particularly scientists in government from Canberra going into regions. There's an expectation, oh boy, here come the scientists from Canberra. What are they going to tell us? And what we need to do is understand just what the matters of concern are for the people that we're trying to communicate with and how they become a matter of concern. One of the things about matters of concern is that they often come about because of pain and failure. Cost of living at the moment is a major matter of concern. Government knows that. They're talking about that as we head into an Australian election. Toilet paper was a matter of concern during COVID lockdowns. Less so now, but it was then. Climate change, is that a matter of concern? Where are we at with that? Yes and no, perhaps. Mineral resources supply chain and cost. Is that a matter of concern? Maybe for some, maybe not universally. I don't know. So communicating that knowledge, and particularly around understanding matters of concern, I'd like to put forward that firstly, it requires us as scientists to be there. Sorry, it's not a best person to quote as an example, but Woody Allen once said that 80% of success was merely turning up and being there. And I think it's the same for us. We often get fixated about getting our PowerPoint presentation right and what we're going to present to people about our science and not realise that sometimes just being there is exactly right. I'll give some examples of that in a minute. And through being there, we actually go on the journey with the community and the people that we're trying to work with. I often talk about the Outback Roadhouse sarsaparilla principle. The example being there is that if you're driving in the Outback and you go past a roadhouse and everything's going great, it's very tempting just to keep going. You go, I'll keep going. Interesting looking roadhouse. I put it to you that if you can, and if possible, particularly if you're in a remote area, it's great when everything's going well to stop at that roadhouse and have a sarsaparilla or a lemonade. The reason is they see you when things are going well. You get to know them, they get to know you. Alternatively, if you don't stop there, just say, hypothetically, your car goes past and then your car rolls over and you have an accident. You remember that there's a roadhouse just back down the road that you want to go to for help, but you're covered in blood and dirt and you're in real strife. You go into that roadhouse and the first they see of you is when you're in trouble and you're most in need. And how much effort it takes for them to understand who you are, what you represent, and where you've come from. If you stop there beforehand, they'll be like, oh yeah, I remember them. They stopped here and they were lovely and we had a good chat and they learned this about us. Makes a hell of a difference. I think it's the same in our science. We often leave that engagement and communication and listening and being there. Too late. We leave it to when we want to actually go out in the field and have a transaction towards land access. So that's what I'm getting at with that one. And the other thing about being there is also to emphasise actively listening and engaging ahead of speaking. And that's a great way to learn what the matters of concern are. I love the way our First Nation elders do this. Worked a bit with these with First Nation communities, and I love the way that the elders kind of let everyone speak. They typically speak late or last, and they absolutely nail it. And it's because they've listened, they've been there, and then they share their knowledge and experience. This has been a big feature of what we've been trying to do at Geoscience Australia in a lot of our First Nation outreach programs, particularly the stuff I'm very aware of that's happened through the Office of Chief Scientists. And really it's about being there, but being better listeners and better partners. And the examples here on the left, you can see Meredith Orr from Geoscience Australia. Here we are working with the Lake Eyre Basin Rangers in just west of Camberwell in Western Queensland on the black soil plains, sharing and exchanging insight and information about that landscape. In the middle, the Russell River, just south of Cairns. This river is currently the largest deliverer of dissolved nitrogen and sediment to the Great Barrier Reef in Queensland. And we've been working with this community about how they can manage and understand their landscape to better look after both the catchment and the reef. This is another one of the Lake Eyre Ranges out at Camberwell Caves. One of my favourite examples was a visit to the Tiwi Islands. Tiwi Islands was an interesting place to visit because there was a lot going on there with offshore resources, right? I think oil and gas, Santos, all those sort of things. And so when I visited there with some Geoscience Australia scientists, there was a slight coldness about who we were and what we were about, because they actually said to us they didn't want us to talk about geology because they thought geology was part of their problem, right? And so it's like, okay. What we did is we went with information on our laptops about the work we do at Geoscience Australia, but we didn't go to present it. We spent a lot of time actually eating grapes and biscuits, and in this case, in the bottom left, listening to the women that were elders. And you know what they were talking about was how where they get food from the shoreline has changed in their lives. They used to get this one here and they used to get this, they don't get that anymore. And at the same time, they were also talking about how their beaches and coastline was eroding. And they took us around a whole lot of different places and sites. And then from that, we were able to target showing them the Digital Earth coastline work. And they were blown away because what that directly showed them was the scientific evidence that they needed to document the coastline changes that they were seeing. And they just wanted to call over all their friends. They wanted to call over all their friends. And I hope I didn't say anything wrong and someone's tithering on that. No, yeah. They wanted to call over all their friends and say, come and listen to this. And what we then got into a discussion about was the whole diversity of geoscience work that we do, including geology and what drives that erosion and so forth. One of the big things about it is that in this area, the erosion, of course, has led to, and is in some ways linked to, the loss of mangroves in this area. When you lose the mangroves, you no longer have those black chemically reducing muds. Those black muds and the mangroves are home to fish and different shellfish, that, the mangrove snails that they love to eat. You lose that, you no longer have that food source available. But what also added to that was you can see the tyre tracks on the beach here, was driving on the beach was breaking down the armour of iron indurated beach sediment. And that forms because of the oxidation of the black muds that are chemically reduced in the mangroves. And when you lose that armour, the erosion happens all the more quickly as well. And so it was a whole sort of cycle and earth system that was changing the food availability and what this community were able to get and could remember that they could get. And it all came back to geoscience and understanding their landscape. So, where does this take us? It actually takes us to that fundamental thing of trust. And it's funny talking about trust. You know that when you mention it, you're going to lose some people because they think it's a bit woke or touchy-feely. But it's actually linked to our value commodity of our science. It's about credibility, the integrity, the intent, capability, and the results. And it's scalar. Individuals have trust, but organisations have trust. Governments have trust. Market has trust. And we can see it when different parts of that break down at times. When we have trust and our work is aligned with people that we trust, we get more done. And that societal trust increases when we can demonstrate public value. The other twist about it is we often think, what can we do to build trust? Well, sadly, it's often a long journey and it's not transactional. The mining company that says, but we sponsor the football team and we put these tennis courts in, why won't they let us build a mine here? Don't get it, right? So and the other funny thing about it is we tend to judge ourselves and our self-trust by our intentions, yet we judge others by their actions and the strong historical bias. In other words, trust can be slow to build, but quickly lost and lost for a long time because of that historical bias. I love this. This is some work by Simon Sinek. He's a bit of a sort of self-helper type in America. Don't worry about that. I love what he's done. What he's looking at, unfortunately that's popped off the screen, the vertical axis is looking at performance versus trust. And he's looking at how he started off with looking at the US Marines and how parts of that group get the best of the best and what their target is to recruit. And performance versus trust is a big one because we all want people with high performance and high trust. But we can't always get them. There's not a lot of them and they're in high demand. So where do we go to? Unfortunately, we don't want people with low performance and low trust. But unfortunately, high performance, low trust is dangerous. Those people tend to be toxic. If you don't believe me and you don't know who those people are, just go to a group and ask them who the biggest arsehole in the team is. It'll be those people. The problem is the performance is something that we tend to measure relatively easily. We have metrics for that. But trust is difficult to measure. So we do find people that use measurement or metrics that are obsessed with that end up running the risk of that high performance, low trust. And that what we find is, in many cases, we're actually better off with people with medium performance, but still high trust. And depending on the job, and this is not scalar, it doesn't mean just because they're low doesn't mean they're zero, is that in some cases, maybe even low performance, but high trust can be valuable for some roles. It's an interesting one. How do we measure trust though? I don't know. And I'd love, if people want to discuss that with me at some stage, I'd love to hear more about it. Just to start wrapping up, the other thing that feeds into this is personal motivation. I find this one fascinates me a lot when I'm working with scientists in government, particularly our group at Geoscience Australia, and looking at the diversity of motivations we have for the science we do, or the role that we do. Some people, believe it or not, are driven by fame, some by fortune, some by status. Some people are obsessed with where they are in the hierarchy, in the pecking order. This is an interesting one. Image and optics. Is it a good look? Is a big motivation for some people. People do it to support their family. Some people are obsessed with building knowledge, their personal well-being, employer. They work for their employer, so they work for the company or they work for the department or the agency. You know, it's a big thing. And people idealistically work for a better world and society. I think we have less of this, but I think we're starting to see signs of it changing. People working more for the nation, for the good of the nation. I think we moved away from it for a while. And there's many, many others. It's not only interesting to think about that for ourselves, but it's interesting to think about how that applies to the people that we work with and the people that we want to influence. Gets back to that matters of concern that I talked about earlier. I find that fascinating here at Geoscience Australia as well. So once again, really interesting one to think about. As scientists, in amongst all that motivation, we often have that challenge of the motivation around our science and our standing as scientists. And part of the reality is that so many of us have been personally dedicated and invested in our skill, knowledge and experience and building that deep domain knowledge, which is really valuable. It's really important, but it's not the whole story. And it does run a risk. And I think when we go down that path, we need to be aware of where we might be heading. What it can lead to is that a measure of our success can become, or the outcome, it can become how we can sustain or maintain our expertise and status that we've invested in, the so-called hero model. And what that means is it can make embracing and leading change and disruption difficult. One of the things I learned when I started at Geoscience Australia, I honestly didn't know about this, you probably hear me talk about it a bit now, is the difference between the credible disruptor and the marginalised maverick. What I'm talking about there, the marginalised maverick I'll start with, is the person that seems to have an answer to everything, seems to know what we should be doing, but are unable to really influence how we do it. Our science community has a lot of those people. And they seem to be very proud in knowing the answer or knowing what we should do, but they don't necessarily have the powers of being a credible disruptor. The credible disruptors are the sort of people that are in the swimming pool and say to the rest of the crowd, come on in, the water's great. Or, hey, get up and dance, this is fun. That's a credible disruptor example. And I didn't know that. That was a huge learning for me because I was, confessional AA sort of time, I was in danger of becoming a marginalised maverick where I was frustrated about that. And so that was an important distinction. The problem is then, if we go down some of that path, we run the risk of being entrenched and institutionalised and actually fearful of our investment toppling over. And I think we see that. And so we can struggle to accept areas also that sit outside of our own expertise. They're almost seen as a threat or a them and us. I went through this a bit. I'm not getting the violin out. I'm just saying that I was a regolith scientist, right? Looking at what geologists refer to when they're kind, they call it dirt. They call it a lot of other things too. So that's surface material, right? Really important for our lives. The number of times I had to hear, but you're not a real geologist. It was just crazy. And I think that's an example of that. And it gets back to what I talked about earlier about that broader definition. I think sometimes when we talk about geoscience, we think that it's a synonym for geology. It's not, or not in the way that we think about geology. Geoscience, as I said, gets back to actually including geospatial work, Earth observation, all of that stuff, because it's about the science of the Earth. Okay, my wrap up is, that's why I'm really passionate about my role as Chief Scientist and working in the Office of Chief Scientist at Geoscience Australia. I think that what I'm doing in that role, or what we aspire to do, is actually look after the fundamental of our trusted science to provide advice, knowledge, and data. The science strategy and the science principles really help guide that. We have an implementation plan that goes with it. But some of the things that we're involved with, I see that we have a key role as the Chief Science Advisor to our CEO, the external engagement of science, external representation of science, so committees and things like that, science integrity, quality and trust, science education, and Geoscience Australia's scientists, who the people, I'm looking at the room here for those online, that are part of our science community and how we are as people. In this upcoming year, our priorities are quite varied. A big one at the moment is how we actually work through the prioritisation transformation that we've got going on at Geoscience Australia at the moment, but there's a whole collection of other things. I've deliberately not listed these because there's not a particular order. They are all important. I'm going to leave you with one final challenge. It all sounds great, Steve. We should all integrate. We should all work together. We should all, sort of have a great sort of huggy moment about our science. But something needs to drive that. And I often wonder, when we talk about integration and breaking down silos, what our real motivation for this is. One of the things that's worked really well in science before is having a moonshot, a major aspirational challenge that draws people together to meet it. And it's an interesting thing to think about. What would be our Australian, and for those that are overseas, international, worldwide moonshot, our giant leap? To be provocative, I'm not going to give a blank screen, but I can see a lot of what we're doing in Geoscience Australia are actually building the foundations and the steps towards what one day might be an Australian geoscience digital twin that not just includes what we see at the surface and the stuff that we're currently building into Digital Atlas, but actually something that's four-dimensional of our continent. And I know that there's some great examples of the parts, but I don't think we've articulated the whole as an agency. So I'll tell you what I told you just very briefly. That broad definition of geoscience, the unique role of the geoscientist in government, the value proposition of trusted, scientific, evidence-based advice, knowledge and understanding, some of the personal characteristics, particularly things like trust, and then lastly, what can we bring together in the future? I want to mess with your brain on that one a bit too. Thank you very much. Thanks for being patient.